Okay, this one we're looking at boiling points, and we're looking at increasing boiling points. So that means that we are going from the lowest to the highest boiling point. And as you can see in my multicolored ink over here, each of these masses are right around 60 gram per mole. And so they're kind of taking the mass portion out of this problem out of the way. So we could think about if they had been different masses, greatly differing masses, we would be able to classify them based off of that because the more massive it is, the more energy is required to change its state. Think of lifting up a little dog but compared to like a Great Dane, it's going to take a lot more energy to lift the Great Dane, something much bigger, than something smaller. So it's taking mass out of the equation. So we can ignore all of those masses. What we're looking at then are the intermolecular forces between molecules. So if you have a big container of butane, or a big container of ethanoic acid, or a big container of propanol, or a big container of propanol, and you're trying to determine what's holding those molecules near to one another in that container. So we look at intermolecular forces. If we look at the first one here, there we go. The butane, those are all, we're going to have some differences in electronegativity values, but all of those electronegativity values are going to be the same. And so we're going to end up equaling each other out, essentially. So we're looking at van der Waals forces here, which we know is the weakest of the intermolecular forces. And so we're going to think that this is probably going to be somewhere near the left side of our list. So here's one where it's on the left side, here's one where it's on the left side, here's one where it's on the left side. So that's probably where we're going to go with this. We can probably rule out C right away. The ethanoic acid has kind of two forces going on here. We've got the van der Waals forces in that bit. We've got a probably dipole-dipole right here, dipole-dipole force, which is the second of our intermolecular forces. But right here we've got a hydrogen bond. So a great difference between the oxygen and the hydrogen electronegativity values makes this highly big electronegativity difference on this end. So we've kind of got two things going on here. So we think that somewhere probably on the highest point here, we've got one here, we've got one here. So these are probably where we're narrowed down to. This probably doesn't make good sense for us. It's not going to be nearly the weakest or the lowest boiling point because it is such a strong intermolecular force. So that gets us down to B and D. Let's take a look at our last two molecules, propanol versus propanol, excuse me. This one mostly is van der Waals on this end. And then this one's mostly van der Waals on this end. The difference being that right here we've got the aldehyde group, which is going to be a dipole-dipole force. There's an electronegativity difference, but not a great one. And then right here, the OH bond gives us another hydrogen bond, which we again know is the strongest of the intermolecular forces. So that means that the dipole-dipole is going to be less. So we should see one right here. It's our second one versus our alcohol group, which is that one. B would be our correct answer. We wouldn't switch those around.